Hello everyone, it's pretty late today, so we're just looking at a single intermediate number theory problem today, and it is I would say a really easy one, and not even really number theory because I would consider it much more algebra than number theory. Okay, so we have the number of sets of two or more consecutive positive integers, and we want them to sum to 100, and we're trying to find how many of these sets are there. So you can pause the video first, and there's actually like two ways they can solve this. One, if you just know the trick, you solve it instantly, or if you just like don't know the trick and you just do some algebra, it's still gonna be pretty fast. So, anyways, I'm still gonna use VS Code as my scratch paper. The first way is obviously the dumb way. Obviously, we have n times 2a plus n minus 1 over 2 is equal to 100 because that's the summation formula. If a is the first term and n is the number of terms, we know n has to be greater than or equal to 2. But so we'll just like expand this first. We'll have 200 over n, correct? And now we have 2a is equal to 1 minus n plus 200 over n. So now we'll just guess and check every single value of n that, first of all, obviously has to be a factor of 200, but also makes a positive integer. And we realize that the only values of n that work are n equals 5 and n equals 8, giving us two solutions. But there's also another smarter way to do this. Well, not really smarter, it's just if you know the trick. And if you don't know it, you can memorize from now on. The number of sets of two or more, not two or more, the number of sets of consecutive positive integers that can sum to any number x is just the number of odd divisors, or factors, I guess, x. Don't ask me why. It's just correct, I guess. It's like a theorem or something that's probably not that hard to prove, but I'm just too lazy to. Anyways, that is it for the problem today. We're just doing one because it's way too late, and I'll see you tomorrow. All right, so here's the grind report. I did follow through on my goal of getting like 5 hours in a day because today's a weekday and my goal is 5 hours for weekdays and 10 hours for weekends. And today I did like 4.5, I guess. If you count this, probably around 5. So yeah, I guess it's pretty good. And it's also a Monday. So if I can just keep this up for the next, I have 6 more school days after this and 2 more weekends. That'll give me 50 hours of grind time after this. So yeah, good enough. Today I did a bunch of number theory until one of my really oldest friends, who she's also really good at number theory, probably the best person I know at number theory, and she told me that there's like no number theory on AMC 10. So I basically look at all these orange. I'm using orange as a color of number theory. Look at all these orange I did. They're just like useless now. So I'm focusing on geometry more, and these are 3 very simple geometry problems that I did after she told me that number theories are useless. And I did reverse the order, so it's easier to tell which ones I did today and which ones I did yesterday. As you can see, both I spent 5 hours. Yesterday I only did these many, but today I started getting better and better at number theory, and also the geometry ones are easy, so I did a lot more today than I did yesterday. If I counted right, I did 8 number theory both today and yesterday, but today I also did 3 more geometry, and it took me less time because yesterday was like over 5 hours, today was less than 5. Okay, thank you for watching, and I'll see you tomorrow. Hopefully I can grind another 5 hours tomorrow.